Number 8. Find the inverse Laplace transform of e to the negative 4s over s times s minus 1. So here, if you look at your Laplace transforms, I have the s times s minus 1 in the denominator. I've got an s in the denominator here, and s minus a in the denominator here, so it could be both of those. But with the e to the negative 4s in the numerator, I want to think second shifting theorem. So second shifting theorem. So inverse Laplace of e to the negative 4s over s times s minus 1. With that e to the negative 4s, when you apply the inverse transform, you're going to get a unit step function with the same shift, e to the negative 4s. This will be u to the t minus 4, and then times the inverse Laplace of f of t, where the t is shifted to t minus a, where a is 4. So I get my unit step function, u of t minus 4, and then the inverse Laplace of 1 over s, s minus 1, where when I apply that inverse transform, my t is going to be shifted to t minus 4. So to get the inverse Laplace transform of 1 over s times s minus 1, we're going to have to use partial fraction decomposition. And so I've set up this fraction to equal the sum of a over s and b over s minus 1. When you multiply through by the common denominator, you get 1 equals a times s minus 1 plus b times s. Combining like terms, you get a plus bs minus a. And then setting coefficients equal to each other, notice here you're going to get, for the constant, negative a is equal to the constant 1. Negative a equals 1, so a is negative 1. And for the s terms, a plus b is equal to 0s, because there's no s term here on the left side. So a plus b is 0, because a is negative 1, b has to be 1. Negative 1 plus 1 is 0. So a is negative 1, b is 1. Substitute those in. A is negative 1 to give you negative 1 over s. B is 1 to give you 1 over s minus 1. And then the inverse Laplace of 1 over s is just 1. And the inverse Laplace of 1 over s minus 1 is e to the 1t. So here I get negative 1 plus e to the t. And then again, we're going to shift from t to t minus 4. So this t and this exponent right here is going to become t minus 4. Sorry, that was out of place. Becomes t minus 4. Notice that this is a unit step function. This is probably the preferred way to write the answer. However, if you want to write your answer as a piecewise defined function, you can. With the unit step function, the value is turned off until you reach this point. So it's turned off until t is equal to 4. So it turned off at 0 until t is equal to 4. And then when t is 4, this value becomes a 1. And so you get what I have in brackets, negative 1 plus e to the t minus 4. So here's the answer written using unit step functions. Here's the answer with the answer written using a piecewise defined function.